Alright, today we're going to be talking about parallel circuit. Watch a video on the series circuit, parallel circuit. It has multiple avenues. Okay, so this is the circuit we use. This is the circuit we use to wire houses, buildings, and everything else. It's parallel. Because if I have an applied voltage of 120 volts, I'll have 120 volts here, 120 volts here, and 120 volts here. But it doesn't change. Okay, my total current would be the sum of all resistors in parallel. The sum of all resistors in parallel. And the total resistance would be less than your smallest resistor. So your resistance is less because we have more amps. Always remember, amperage, and I forgot to say it in the last video, amperage and current are inversely proportional. So if my amperage goes up, my resistance goes down. If my resistance goes up, my amperage comes down. Okay, and then I'll show you on the different circuits. So I'm going to label these R1, R2, and R3. My voltage is 120 volts. I'm just going to say 3 ohms. Change that. $10 ohms, 20 ohms, and 30 ohms. Alright, so I got a 10 ohm, 20 ohm, and a 30 ohm. So my sum, my total resistance would be the sum. My total current would be the sum of all three resistors. Going back to the formulas. E, I, R, P, I, E. So this is my volts. This is my resistance. This is my amps or current. Okay, this is my watts. P is for power and watts. I is for current. E is for volts. It doesn't change. Okay, that doesn't change. So if I want to find the amperage, now I want to find the amperage for each individual resistor. So I equals E divided by R. Okay, so it would be 120 divided by 10. So 120 divided by 10 is 12 amps. 120 divided by 20 is 6. So this would be 6 amps. And then 120 divided by 30 would be 4 amps. Okay. So as you notice, as my resistance increased, my amperage decreased. My total current, okay, my total current, and again, it's just the simple formula, and I used it for all. So it'd be 120 divided by 20, and 120 divided by 30. And that's why I got the last one. So this is volts, ohms, volts, ohms, volts, ohms. This is R1, R2, and R3. Alright? My total resistance, my total current is the sum of all resistors. In the series circuit, my total resistance, I had a constant on the current. Here now, I got a constant across here. So if I get my amp probe and I clamp it here or here, it's going to give me 12 amps. If I clamp it here or here, it's going to give me 6 amps. If I clamp it here or here, and then it's going to give me 4 amps. I mean, I can clamp it here, it's still going to give me before. Okay, now if I clamped it here, let me get to the, okay, so here's a 1, here's a 2, here's a 3, here's a 4, and here's a 5. Okay, so if I go to 1, I'm only going to read the resistance of that. If I go to 2, I'm going to read the resistance of that. If I go to 3, I'm going to pick up the resistance of these two, which would be 10 amps. So if I get my amp probe and I clamp it here at the number 3, it's going to be 10 amps. If I clamp it at number 4, it's only going to be 12 amps. Okay. If I clamp it here, now it's going to be the sum of all 3 resistors in parallel. Okay. So I total. Okay. The T stands for total. The D stands for drum. Talked about that last week. Is I1 plus I2 plus I3. I total equals 4 and 6 is 12 and 10, 22 amps. So my total is 22 amps. There's different ways of finding total resistance. There's different ways of finding total resistance. Okay, so if I want to find my total resistance, it would be my E divided by I. Okay, so my formula for R total equals E divided by I total. Okay, very simple. E divided by I total. So here I'm going to get the 120. I'm going to divide it by 22. Get my calculator. So 120 divided by 22 equals 5.454545, and I just reach it to 5. Let me go back one step. Okay, so if it goes 45454545. I can round it off here, so it would be 45 or 455, whichever way you want. Okay, that is how you find total resistance. Okay, I have voltage and I found my total current. Easiest way to do it. If you have your voltage applied and your total current, and that's the easiest way to do it. But sometimes you may not have a voltage. So sometimes I got a circuit, it's got 10 ohms, 20 ohms, and 30 ohms. How do I find total resistance? How do I find total resistance? There's a quick formula. There's 2 formulas. It's R total equals R1 times R2, or R1 divided by R1 plus R2. Okay. Well, I'm only showing 2 resistors here, and I got 3. Okay, I'll do this formula twice. So I would go to the end, start here, shrink this down into 1, and then do it here. Okay, that's one way to do it. I won't do it both ways, so I'll show you. Okay, so I hope we all got this here. We got the current. I'm going to erase this current real quick. I'm giving myself some room here. Okay. There's when we did it the other way. The other is R total equals 1 over R1 plus 1 over R2 plus 1 over R3. I'll get back to this in a bit. So this is basically our formula we're going to do. So because in order to add them, we have to have a common denominator. So 1 over RT comes over. So it's going to be RT equals 1 over, so we need something that all these 3 would go into. So I'm going to say 60. Okay. 10 goes into 60. 6 times, plus 20 goes into 60 3 times, plus 30 goes into 60 2 times. Okay, you got to remember is it's a reciprocal, we flipped it. So we have to have a common denominator, so we turned this 1 into a 60. And then we divided our 1 into that 60 to give us the top number. Okay, so we got it across. So now all we have to do is add. RT over 60 equals. Okay, so 6 and 3 is 9. And 2 is 11. Again, it was a reciprocal, so we have to flip it back. So we're going to have 60 divided by 11. RT equals. Okay, get my calculator. 60 divided by 11 equals 5.4545. I'm just going to make that last one a 5. Identical. Identical. Okay. Now, how do we use this formula? So, come over here. RT equals 20 times 30 and 20 plus 30. I'm going to go to the end. And we'll start there and work back. RT equals, so that is 2 times 3 is 600 divided by 50. RT is 600 divided by 50 equals 12. Okay. So what we did is we took all of these two at the end. Now we just shrinked into 1, and we changed it to a 12 ohm. So we go back, we do the formula again. Okay. RT equals R1. So we move this one, change this to 2. R1. I already know the formula. I'm going to write the number down. So it's 10 times 12. 10 plus 12. Okay. RT equals 10 times 12 is 120. 10 plus 2 is 22. We did it already here. 120 divided by 22 equals 5.45455. I just rounded up at the end there. You have to be very careful when you're rounding off numbers. You have to be very careful when you're rounding off numbers. Sometimes it don't work. Sometimes it don't work. So if you round off, you're not going to get, they're going to be uneven. They're not going to match up. So when you do it this way, they'll match up the first time. When you do it this way, because a number exists, you know, in order to get the exact number, you have to put all the numbers pop up in your calculator. So I did it, I found total resistance 3 different ways. So I found it using the RT equals R1 times R2, R1 plus R2, and then I use fractions, and then I use my total current and my total voltage. Okay, so we did it 3 different ways, and we got the exact same answer all 3 times. Alright, let me erase this. This was 6 amps, and this was 4 amps. Okay. So now define watts. Okay, now we have total resistance. We have total resistance. I've done it 3 different ways. I'm going to erase this off so I can give you some room to do the wattage. And this is unequal resistors. Unequal resistors. Okay, equal resistors, I'll give you that in a bit. Okay, there's 120 volts. P equals equals I times E. Because these are individual branches. Okay. In parallel, these are considered individual branches. When we had a series circuit, well, there's only one direction of current flow. Now we have multiple directions of current flow. So this one has 120, this one has 120, this one has 120. Okay, I'm just going to, for intended purposes, I'm going to put a negative there, and plus here. And like I did on the series circuit, it's trying to get from a negative state to a positive state. It's coming across. When my voltage goes across here, it gets to this number 4 here, right here, it's going to be at 0. As voltage comes across here and it gets across that 20 ohm resistance, it's at 0. Comes across here, it's at 0. And it's doing this 60 times a second. It's going, it's coming, it's going, it's coming, it's going, it's coming, it's going, it's coming. Okay? That's how electricity works. That's why you have 60 cycles. It's cycling 60 times a second. It's cycling 60 times a second. So, here, P, we get to this first one, and it's going to be 12 times 120 volts. Amps, volts. Okay. 12 times 120 equals 1440 watts. Okay, get the next one. 6 times 120. 720 watts. And then 4 times 120. That is 480 watts. Okay. If I wanted P total, it's a sum of all. So 720 plus 480 plus 1440 equals, multiply that 6 times. It's 2,640 watts. Okay. Is this correct? We can check it. I equals P divided by E. So 2,640 watts divided by 120. Divided by 120 equals 20. Okay. Or E equals P divided by I. 2640 watts divided by 22. E equals 120 volts. So we checked everything. Everything comes out. So we just found our total resistance. We already know each individual resistor. We found each individual amperage. We found our total amperage by adding them all up. We found the individual wattage. We found the total wattage by adding them up. We checked it. So we got the total wattage divided by the voltage. And we got our amperage. And then we got our total wattage divided by our amperage. And we got, by amperage, and we got the 120 volts. Okay, so this is the parallel circuit. This is how we use wire building. This is what we use wire building. Okay, watch this and watch the video first, and then do your homework. And this is how you do it. All right.